Inference in regression. How do we test whether the slope is real and build confidence intervals? We computed a slope from our sample, but that's just one sample. The real question is, does the population slope, beta, actually differ from 0? Our sample gives us B1, but we need inference to say something about the true population parameter beta. The population regression model says each observation, yi equals alpha plus beta times xi plus a random error epsilon I alpha, is the population intercept. Beta is the population slope we want to test, and epsilon is random variation. The standard error of the regression estimates how much the actual values scatter around the fitted line. To test whether the slope is real, we set up a hypothesis test. The null hypothesis says beta equals 0, meaning there is no linear relationship. The alternative says beta is not 0. We compute a t-statistic by dividing the sample slope by its standard error, with n-2 degrees of freedom. Under the null hypothesis, this t-statistic follows a t-distribution. If our t falls in the rejection regions in the tails, we reject the null and conclude the slope is significant. Let's apply this to the doll smoking data with 11 countries. We test H0, beta equals 0 versus beta not equal to 0. Our slope is 0.0339 with a standard error of 0.0088. The t-statistic is 3.85 with 9 degrees of freedom. The p-value is about 0.004, well below 0.05, so we reject the null hypothesis. There is a statistically significant linear relationship between cigarette consumption and lung cancer mortality. We can also build a confidence interval for the slope. The formula is b1 plus or minus t star times the standard error. For our data, this gives 0.0339 plus or minus 0.0199, resulting in the interval from 0.014 to 0.054. On the number line, notice the entire interval is above 0. Since 0 is not included, we confirm the slope is statistically significant. Regression inference requires 4 conditions, easy to remember with the acronym LINE. L for linearity, the true relationship must be linear. I for independence, observations should be independent. N for normality, at each x, the errors follow a normal distribution. E for equal variance, also called homoscedasticity, the spread of y should be the same at every level of x. To recap, we test whether the population slope beta is 0 using a t-test with n-2 degrees of freedom. A small p-value means the slope is significant. We can build a confidence interval for beta. If 0 is not in the interval, the relationship is significant. And always check the line conditions before trusting your inference.